Okay, so let's start with number 9 just to see. A lot of times they don't give you your work in standard in the form that you want it. You always love it when they give you y equals something x plus something else because that's your slope-intercept form, right? But what if they don't give it to you that way? What do you got to do then? No, you're not goofed. You just have to solve for y, right? When you think about y-intercept form, isn't it y equal mx plus b? And isn't the y by itself? So if I get something like number 9 there, wait, we're doing evens, right? I don't want to do, 10 would be an even, and I want to do one that's assigned. I'm going to try to do it up here and hope that my answer doesn't lie where my writing is on this thing. Okay, so 10 is 3x plus 5y is 10. And we're supposed to graph it, and it says use the slope and y-intercept where possible. What you usually do when you get something like this is solve for the y term. And do you remember, a lot of people think that, a lot of people kind of get confused about moving stuff from side to side. Can't I move anything from side to side as long as I keep the whole term together just by adding the opposite? Or, like for instance, I got a 3x here. I could add a negative 3x, but that's the same thing as subtracting 3x, isn't it? So I'm just going to write minus 3x. Be careful here that you remember how to combine things properly. That would end up with 5y is equal to, always go ahead and write that x term first. It's not wrong if you don't, but if you're trying to get it look like y equal mx plus b, won't it look more like it if you put your x term first so that you're less likely to get your slope and your y-intercept mixed up? So even though that's negative, I'm just going to write negative 3x. That was a positive 10, so I'm going to put plus 10 because that 10 really did have a plus sign in front of it. It's a positive 10. It's just lazy mathematicians don't write it. And so I can just switch the order of this and just keep the sign with it and write it that way. If I want to get y by itself, what's the last step I need to do here? Yes, and when you divide by 5, remember that everything gets divided by 5. The pre-cal students took a test, and some of them forgot that, and so they got their y-intercepts wrong because they only divided their slopes. They just went over lines again too. So we have y equal, does the negative go at the top or the bottom on that 3/5? Doesn't matter. Just don't put it on both, right? You pick one and you stick with it. Since I happen to have mine that looks like it's with my x, I'm just going to keep writing it that way. Is it okay if I write it like this with the x in the fraction in front of it? Yeah, it means the same thing, doesn't it? So that kind of helps it see the slope a little bit easier there. And then what's 10 divided by 5? 2. Okay, so this is now in y equal mx plus b form. I wish this iPad would pick up my marks. Here we go. So my starting point is what? 2. It's the number, the constant term, the number that's not with the x. So I go to that's my y-intercept. So I go to my y-axis and I color that in. And then, what do I do to get another point? Because any line has to have 2 points, right? We learned that in geometry. Count off the slope, is that what you're saying?
Oh, rise over rise.
Rise over, yeah.
I was thinking of something different.
Oh, sorry, okay. I thought you meant that because, but the slope is the number in front of the x, and we take the sign with it. So my slope is negative 3/5. Let me write that down here. I happened, oh, come on, please pick up. I happened to write the negative with my 3. You could have put it with the 5 here, but then you might want to write, if you're having trouble graphing anything, you might want to write rise for the top and run, just so you're kind of reminding yourself that's what I'm going to count off here in a minute, right? And that word rise, that reminds us of an elevator that goes up and down. So positive numbers would go up like an elevator would go up, and negative numbers, we'd look at it as the elevator going down. So since I have a negative 3, what does that mean I'm going to do? Yeah, I'm going to go down 3, right? So that would put me at the negative 1, but there's not really a point there. I'm in the middle of counting, aren't I? And now I'm going to run 5, run across the floor horizontally, right? And so we're going to go in a horizontal direction, and it's positive, and the positive numbers are to the right, so we're going to count right 5. 1, 2, 3, 4, 5. So the only points I really have on there are these two big ones. Those little ones were me just dotting it as I counted, right? And I know, like, I remember, I think it was y'all's class, there were some people that were getting that kind of mixed up and thought that all of these were dots. But that's counting the rise over run. It's a two-part thing, so sometimes just to keep on track. We might make little dots, but really our only 2 points are these two, and I can draw my line through it. And, of course, I missed that one a little bit, but you kind of get the general idea, right? And what form was this equation in? 3x plus 5y is 10. Remember what you called that? Slope-intercept is what I put it in when I saw for y. This over here is slope-intercept. Well, there is a point slope. This one, I can't get this thing to take anything I write today. This up here that it was given to me, and that's called standard form or general form. Most books call it standard form. I think your book may call it general form. Typically you say standard form, but I'm learning all kinds of books use all kinds of things. Even in our pre-cal book, there's stuff kind of backwards than what it is in this book. So, shoot, I didn't turn the thing on. You can look at y is -5. Y is always -5 no matter what x you pick. I missed most of that recording it. Let's look at 20. What is 20 telling us? X is always 0. Does it matter what my y is? No, because x is always 0. So I might have a point. Let me do this one in red. I might have x is 0 and y can be anything. It could be 3. You're right, Misha. It's a vertical line, isn't it? X is always 0, but my y could be -3 if I wanted it to be. It could be -7. It could be 9. It could be anything, right? So when I connect those points, you get the vertical line. So if you remember, x equal a number is always a vertical line. I don't know what I'm going to do to get this thing to take. Vertical line. And y equal a number is always a horizontal line. One way some people, if you get them mixed up and you can't think through it, or maybe you've just talked yourself into confusion because you're trying to figure it out on a test and you're so stressed. Some people say that if you write your y kind of like a girly y like I did, that you can see the upside down h in it for horizontal. I don't know. Some people don't write their y's that way, so it's not as obvious. Some people write their y's like this.
Why would they do that?
Just different people write different ways, right? And for the vertical line, they say you can see the V sitting here on it, the real sharp V. That only works if you write girly y's. So you got to be careful with these little memory devices. They can lead us astray, or confuse us. Okay, so for 14, the equation was y equal -2x. Is this in slope-intercept form? What'd you say? Well, the slope's not 0, but something is 0. You're right to be thinking about 0. Something's missing, right? The starting point is 0, because that's what's missing in it. There's no number on the end, right? Isn't -2x the same thing as -2x plus 0? And if we were to add -2x plus 0, we would just write it as -2x. And the reason that they don't put the plus 0 on there is because a lazy mathematician is not going to write the plus 0 because it's equivalent to something shorter. Yeah, he's just being lazy, right? It would help us if he did, because then we would remember, oh, the number on the end is my y-intercept, so that's my starting point. Honestly. Well, you have to do so much thinking. You don't want the words in the way, So there's my starting point. How am I going to count my slope off here? What is my slope?
Run -2 is on top.
-2 is the slope.
You could put -1, but it doesn't really matter as long as you don't have -2 and -1.
Right. As long as what I get written down here is still -2, I could have left 2 positive and 1 negative. Just don't put it on both. I'll show you why there might be an advantage to switching it sometimes in a second. If I count this, if I think that's rise over run, The negative 2 on top means rise negative 2. Well, the elevator would be like going down if you're thinking of an elevator analogy. And then run 1. 1 is positive, so you're going to run to the right 1. Those big ones are your points. Those big blue dots are your points. And then we could draw through them. When I did my rise as negative 2 and my run is 1, that gave me a point below the point I started with. Have you ever been trying to graph a problem and maybe you were down, your starting point was like negative 9 or something, it's so close to the bottom that you can't go down any further and you think, what am I going to do? If you ever run out of space on your graph, because you're too close to one edge and you're trying to go up or down and you'd run off the edge of it, here's what you do. You could say, well, I tried to go down with the rise negative 2, run 1, but the fraction 2 over negative 1, just put the negative on the bottom, would be another way to do it, right? I mean, that's still isn't 2 over negative 1 equivalent to negative 2 divided by 1? As long as the values are the same, you can write the fraction any way you want to. So what I could do to get another point on this line, let's say I was running out of space here at the bottom and I needed to go up because I just didn't have any room. That's not really the case here, but just what if it happened? I could say, okay, here was my starting point, count up to, and then the negative 1 would be to the left 1. It still landed on the line. And if I want to fill in that line, if I know the slope is up 2 over 1, couldn't I keep going with it? You could fill in and get really good accurate lines if you just kind of keep going with your slope. Up 2 over 1. Oh, there's another point. Up 2 over 1. Oh, there's another point. Up 2 over 1. Oh, there's another point. Got my drift? Up 2 over 1. I could get a very, more accurate graph if I'm trying to freehand, and I still can't manage to hit the points with the stylus, but you can, you can just keep counting that slope off from wherever you land, just keep counting it off from that point you landed on, and you can get all these points graphed, and, sometimes that matters if you're trying to answer a question based on a graph, like, what is x when y is negative 4? Oh, well, since I extended it, I'm sorry, what is y when x is negative 4? Y is 8. I can see that really easily because I can just trace right on up there. And that's what I think. If y'all's SAT changes, I think there might be things like that on there, just little things they add into the line stuff to see if you understand how to read a graph.